Alright, section 2.5 is still continuing with derivatives, but this is called implicit differentiation. So what you're seeing here is actually an explanation of the difference in when something's written in explicit form versus implicit form. When your equation is solved for y, you've got y on one side by itself, and this is in terms of x, then that's referred to as explicit form. If your equation basically is written with just a mixture of your x's and y's, in which you don't have your y isolated, then that's referred to as implicit form. So that's what we're going to be looking at here, is dealing with equations that are implicit form and learning how to take the derivative when it's in that form. Now, if you can take an equation and easily solve it for y, which actually this equation and this equation are the same, because if you were to get y by itself, solve this for y, then you would have this equation. So if you wanted to turn it into, or turn it from implicit form to explicit form, to do the differentiation, then you could, but there are many things in which you cannot easily solve for y, so that's why we have to deal with this implicit form. Alright, so here's an explanation concerning implicit form. And as it states, to understand how to find dy dx, remember that's a notation for derivative. So if you're going to find dy dx implicitly, you must realize that the differentiation is taking place with respect to x. And when we first started talking about notation for derivatives, the way I had explained this notation is that you're taking the derivative of y, but with respect to x. So that would be, with it in the explicit form, which is the way all of your problems have been up to this point. You're taking the derivative of this y function with respect to x, because that is your only variable that you're dealing with in those functions. So this means that when you differentiate terms involving x alone, you can differentiate those as usual. Okay, so using any of the rules that we have previously learned about derivatives, if your term involves only x, then you just do it as normal. However, when you differentiate terms involving y, you must apply the chain rule. So I'll give you an explanation of what that means as we start working some examples here. Okay, so first example, you're asked to take the derivative with respect to x of x cubed. So as I've pointed out here, you're asked to take the derivative with respect to x, and the term that you are asked to take the derivative of is only in terms of x. So as I've pointed out, these two variables agree with each other, so that just simply means that you're going to be taking the derivative as usual, as that previous note had told you. When it involves only x, just do it as normal. So this is just simply doing a power rule. So you would have your power times x to 1 less power. Okay, so that's exactly what it means. If it's in terms of x, just do it as normal. Now the second example that you're seeing here, your variables do not agree with each other. You're asked to take the derivative with respect to x, but the term that you're taking the derivative of is not in terms of x, it's in terms of y. Now you're actually going to use the rule, like in this case the power rule, just as you're accustomed to doing, but there'll be one little thing in the end that we have to deal with. So starting out with power rule, I would have 3 times y to 1 less power. But then you're going to, remember chain rule means you multiply by the derivative of the inside. So what that means is, because you're asked to do this with respect to x, but yet you have a y, y is representing some function that you're unsure of what that function is. So in that case, meaning you really don't know what the inside function is. So to represent that you're doing the chain rule, you're basically just going to have to use the notation for derivative. So when you say that you're taking the derivative of the inside, then that would have just to be dy dx, because you're taking the derivative of a y, but you're asked to do it with respect to x. So your derivative for this is exactly what you see here, 3y squared dy dx. So like I said, y is representing something that we're unsure of, so therefore we can't have a definite derivative rule that we're going to use. We're just going to say, hey, we're going to take the derivative of y with respect to x, and that's what this is telling you. Okay, next one. Okay, again, we're asked to take the derivative with respect to x. Now, you have a sum, so if you remember, when you have a sum, you're allowed to take the derivative of those terms individually. So, first of all, you're going to take the derivative of x. Well, that's a term that involves only x, therefore you'll do that as usual, so the derivative of x would just be 1. Okay, then bring over your plus sign. Now we're going to take the derivative of 3y. Okay, now, you take the derivative as usual, use the usual rule here, of course, technically, which is power rule, because this is to the first power. So this is going to end up giving you, the derivative is going to end up giving you 3, but because this is a term involving y, you apply chain rule and you multiply by dy dx, which just means, again, you're taking the derivative of y with respect to x. We just don't know for sure what y represents. So this would be your implicit differentiation for this. Okay, so now we're asked to take the derivative with respect to x of x times y squared. Now, since what I have here is being multiplied, this is going to require that I use the product rule. So go about your product rule just as usual. So you'll have first function times the derivative of the second function. Now, your second function is in terms of y. So this is where you've got to remember to apply that chain rule. Okay, so just starting out, you've got your power rule, so that would be 2 times y to 1 less power, but you have to apply the chain rule, and you would have dy dx. Okay, so this is first function times the derivative of the second function, plus second function times the derivative of the first. So the derivative of x would just be 1. Okay, so just rewriting this so things look a little nicer here. You could write this as 2xy dy dx plus, of course, y squared times 1 would just be y squared.